To begin testing for my n-body simulation, I will be testing the login system, the registration system, and the ability for a user to reset their password. Okay, so I've gotten open 5 different classes, all of these combined to make this system. So I have also gotten open my database. Within this, I am in my login details table. In this, I have a unique user ID, a name, username, email, and password. So we will start by opening up our main menu. Within this, we are prompted to either enter or log in. When you enter, you do not have an account. You are not logged in as a user, and therefore you cannot save or load any simulations. So to start our testing, we will first begin by testing registration. We get prompted with a login screen, and we have to choose to register. I will now input test data. And after pressing this register button, it should give us a prompt to say we have registered. Now we have registered, we are taken back to the login screen, and I can check my database to see if all the data has came in correct. So all of my data is correct, and I've also been given a unique user ID. And now to go into my registration class, we can see how this is done. So within my registration class, we have got a while loop to keep creating a new random integer if the ID is not unique, dictated by this method here. So now moving on, with this test data that we have created, a username of test and a password of password, we'll go into our menu again and go to login with our username test, our password. Once we press login, this should prompt us that we have successfully logged in and take us into the simulation. There we go. We can now exit out, and next we'll want to test to see if we can reset our password. So we'll go to login and go to reset. So the password, this will be the new password that you want to set. And we will enter the email that we used to log in. And if the email matches up correctly, it should reset. There we go. We can also test this again by entering the wrong email. Upon entering the wrong email, we are prompted that the email was not found. Now, if we go into this and we check whether the password has reset, as we can see, the password has reset to what we put it as. Now we can go back into our database and we can see that our password has been reset. For our next bit of testing, we will be testing our basic fundamental controls of the system. These controls allow the user to do the basics such as starting, stopping, resetting and exiting the system, alongside toggling the side panel and undoing the last body which was added. Here are the methods for the buttons. Within the start simulation, we have to set that the simulation is running. And within the side panel, we have the time step slider. This time step slider gets the inputted value of time steps from the user. This dictates how fast the simulation will be running. The stop simulation just sets the time step back to 0. The reset simulation method clears all the bodies from the array and repaints the simulation panel. We will currently skip over undo last body due to the fact that this will come later in testing when we are testing adding and removing bodies. To begin, we will run the simulation and enter as a guest. At the top, we have our 3 tabs. The first tab contains our system controls and all the buttons that I have just explained. First, we will test the toggling of the side panel. When we press this once, this side panel that you can see on here should disappear, and when we press it again, it should come back. That's pressed once, and that's pressed twice. This is used due to the fact that it takes up a majority part of the screen, and therefore a lot of bodies can be hidden by the side panel, which we do not want, as we want the user to fully be able to use the entire simulation panel. We will skip over undo like I said. Next is the start and the stop buttons, but to test these, we will have to increase the time steps and also add bodies to our simulation. On pressing start, all of the bodies should start moving together as there is a force between them being calculated, and the animation will begin. As we can see this works, we can press stop to stop the calculations and animation, which, as you can see, this has completely stopped all of the bodies from moving, and we can test it once again. Reset button should remove the bodies from the array and then repaint the simulation panel so that the bodies are gone. Now that we have tested all the main fundamental buttons, we can exit out of the simulation with the last button. This should dispose of the frame and end the program. As so. For our next bit of testing, we will be testing the functionality of loading and testing simulations. Within this, we have our saving and loading class, which incorporates my database and the remaining two tables. The first table is the simulation table. This includes a simulation ID, which is unique to every simulation, a simulation name, which is inputted by the user ID, which acts as a foreign key to the unique ID, which is given to each user, the time step, theta, vectors, traces, and elastic. These are all variables which are set by the user. Our next table is the bodies table. Within this, each body is given its respective variables which are set by the user and are all linked to the simulation by the foreign key simulation ID. To begin testing this, we will first test what happens when you try to save and load and you do not have a user logged in. At the top, we have our three tabs. The first is the controls, next is saving, and next is loading. Within our save panel, we are given a text field and the button to save. As we are currently not logged in, if I attempt to save, we will be prompted with a message saying that we are not logged in and we cannot save. Similarly, if we are not logged in and we attempt to load any files, it will give us a prompt saying that we are not logged in and we cannot load. We can now exit out and test saving and loading when we are logged into our test account. Here we can see our test details, our username being test and password 1. Now that I am logged in, I can enter the name which I want our simulation to have. And to check that all the bodies are being added correctly, I will add 4 different bodies. Each with separate variables, different velocities, different masses and radiuses. We will also have to change the basic simulation variables such as the time steps, theta, traces, vectors, and elastic. I will all turn on just so that we can test that they're all being read in correctly. I will now run the simulation to see how it works. Now we have seen the basic trajectory of the bodies. We will save the simulation. We are now prompted with a message saying that it has been saved. We will now exit out and check in our database. We now have a new simulation with a unique ID, the inputted name, the foreign key linking to our signed in user, the time step variables, the theta value, and all of these are 1 due to them being true. If they were 0, it would be false. Within our bodies table, we have our linking simulation ID, which links to the simulation we just created, alongside all the bodies with different x velocities, y velocities, and different positions. Now that we have saved our simulation, we will go to test loading. To load the simulation, we need to log in with the same user that we created the simulation on. For us, that would be our test user. Once we are logged in, we can go over to the load tab and we have one singular button called show files. This should pop up a list of all the simulations that we have created. For us, it should just be the one. And it shows up with a button called test simulation. Upon pressing this button, it should add all 4 of the bodies that we placed and it should run the simulation. As you can see, it ran the simulation with vectors on, traces on, elastic collisions on, and it worked as intended. For my next part of testing, I'll be testing adding bodies into my simulation in various different ways to provide user variety. So to begin, I'll enter my simulation as a guest. Now that we are in our simulation, on our right hand side we can see the tabs for controls, maths, and preset simulations. For now we're going to be focusing on the controls. Within this we can set the variables for the bodies, which includes the x and y velocities. Within this we can choose the body's variables, which includes the x and y velocity, the mass of the body, the time step is the speed of the simulation, the radius of the body, theta is a variable which dictates the amount of approximation which is done. The first and most easy way to add bodies, which we will be testing, is on click. So if we set the variables for these bodies, now to add a body we can click anywhere within our simulation panel, even behind the side panel, and on doing that it should add a body on the point that was clicked. Now that we can see the bodies have been drawn, we can test to see if they have been inserted into my quadtree and calculation is being done on them by starting the simulation. Okay, so we have now tested adding bodies on click. Now the next way to add bodies is to choose the specific x and y positions of the bodies. And upon clicking the add body button, it should add a body with this mass, this radius, and in this position. So as we can see, that is 500 along and 500 down. And there, now this one is 250 along and 250 down. So now we know that our X and Y position text fields are being read in and the add body button is working. We will test to see if they have been added into the quadtree and if the calculation works. Now that was the 2 main ways of choosing the position for the bodies to be added in. Now the last way is by using a random value. Now the random value is selected, we can either click on the simulation panel, which will input a body into a random point within this entire simulation panel, or we can press add body, which will do the same thing. Now I will click on the simulation panel and a body should appear somewhere in the area. There's once, there's twice. Now I will do the same thing by pressing the add body button. And as you can see, the body has appeared here. Now we can test to see if it works by pressing start. As you can see, the bodies have been attracted to each other and calculation is working. I will now be testing the undo button. The undo button should remove all of the bodies in the same order that they were added. For example, If I added 3 bodies, 1, 2, 3, it should remove the last one, and then the second last, and then the first one that was added. And that's exactly what it does. And we can also test it during the simulation. So first it should be the middle, then bottom left, bottom right, top left. So middle, bottom left, bottom right, top left. So as we can see, the undo button works perfectly there. For my final bit of testing, I will test to see if the undo button works within preset simulations. And it does. Next up for the testing will be the additional features I've added, just for variety and extra user interaction. Now we're in our program. The first thing we want to test is traces. Traces should plot the path of the bodies as they're moving and as they're being animated. So upon turning on traces and starting my simulation, as we can see, from the starting point to the point they're at, it is drawing the traces. Next, we want to check what happens when we uncheck the box and check it again. So the previous path has been discarded, and it starts drawing from the next point at which it was turned on. Our next additional feature will be vectors. Vectors show the direction of the resultant force on each body. So the force on this body is pointing in this direction, therefore acceleration will be in this direction. We want these vectors to be dynamically changing as the bodies move, because the center of mass will be changing as they move. So upon starting, as you can see, these vectors have changed direction as the angle is much shallower and they are pointing more closely towards each other. This is due to the fact that these top two bodies have less of an effect on these two bodies as these are so much closer together. For our next feature, we want to test elastic collisions. With elastic collisions off, when bodies collide, they should combine rather than bouncing off of each other. As you can see, all three of the bodies have combined into one singular body. This will have the mass of the sum of each body. Now, once we select elastic collisions, this means kinetic energy is conserved and the bodies do not combine, and therefore they will bounce off of each other. As you can see, elastic collisions worked as the bodies moved off without combining together. The last feature is the use of definition or explanation buttons. These provide extra information for the users for variables which they may not understand, such as theta. And then we have a prompt, which is called theta explanation, and it explains what the variable is and how they should use it. Theta is the variable which discerns the amount of approximation which is done. The greater theta is, the less approximation is done. Within our mathematics tab, we have a button to show the force distance graph. This shows a graph of distance against force, where distance is on the y-axis and force is on the x-axis. This is to show the inverse square law that is presented by Newton's law of gravitation. To be able to display this graph, you have to have a simulation with only two singular bodies. This is due to the fact that you have to use a singular linear distance between the two. Upon starting a simulation, the axes of the graph should be drawn, and it should start plotting the line. As you can see, as the distance is decreasing, the force is increasing. And this is in an inverse square law way. Next, we will be testing our preset simulations. I've personally built these preset simulations by adding bodies with specific variables such as specific masses, positions, and velocities. Upon entering the simulation, when we go over to the three tabs on the side, we are given a preset simulations tab. In this, we are given 4 different simulations. We will be testing that all 4 of them add the bodies onto the simulation panel and act as they should. The first one is the solar system. This one should include one body, which is the sun in the center that is not moving, and orbiting bodies which are moving around it with their respective names following along. So as we can see, we have the sun, we have every single planet in order orbiting around the sun with approximated distances between them. Upon clicking reset, the simulation resets and all the bodies are discarded. Another test I want to do with these preset simulations is to see whether traces, vectors, and elastic collisions also work with them. So to begin, I will add the solar system once again, and I will turn on traces, and I will turn on vectors. As you can see, each body's vector is pointing towards the sun. This is due to the fact that it has the largest mass and therefore the largest force. Now that we know these simulations act accordingly with traces and vectors, we will add the rest of the simulations with traces and vectors on. And the next simulation is Earth satellite. This should include one large body which is stationary, being the Earth, and one satellite which is orbiting around the Earth. And this specific satellite is the Hubble satellite, and it shows the relative distance between them. The next simulation takes in a prompt. This is called number of bodies. Spiral galaxy should draw one large central body alongside lots of small bodies orbiting around it. This is to demonstrate what a galaxy should look like. I will be testing this with 500 bodies, which is typical normal data. As you can see, we have one large central body which is not moving, and all of these bodies orbiting around it. And eventually all of these bodies should separate out of this orbit, and they should all start spiraling around this single point. As you can see, traces and vectors also work on a large amount of bodies. The last and final simulation is called spinning. This should add 2 bodies which are orbiting around each other, going in different directions. This is a 2-body simulation, which I have added due to the fact that in the mathematics tab, the show force distance graph can only be done on a 2-body simulation. Upon adding it, we can see the bodies are constantly moving in different directions and orbiting around each other. The final bit of testing I would like to do with my preset simulation is adding your own bodies to these simulations. I will do this by using the spiral galaxy simulation. So after adding the spiral galaxy simulation, you can see that bodies are orbiting around with their vectors pointing towards the large point mass. For my next bit of testing, I'll be adding my own bodies with their own respective variables to see if it acts accordingly with the bodies already added from the preset simulation. As you can see, my body is in orbit now. So now we have seen we can manipulate and change our preset simulations by adding our own body. I will be testing all of the normal, extreme, and erroneous data that I could think of that may affect my simulation. To begin, I'll be testing a normal amount of bodies to place in the simulation and extreme values for the number of bodies. To test this, I will be increasing the number of bodies, and I have got random values selected so the bodies will be placed at random points throughout the simulation panel. To begin, I will add 100 bodies. I will also be selecting elastic collisions so that the bodies do not combine and we can see how well the simulation copes with larger numbers. As you can see, with 100 bodies, the simulation is running smoothly. Next, I will add 500 bodies. As you can see, 500 bodies coped well, though there was a lot of bodies being shot out, and this is due to the fact that there's a larger amount of bodies, so there's a larger force on every single body. Next, we will be testing 1000 bodies. As you can see, with 1000 bodies, the simulation starts slowing down, and it is not working at full efficiency. Next, we'll be testing 1500 bodies. As you can tell, now that we have reached about 1500 bodies, the simulation has slowed down exponentially. To finally round off testing the number of bodies, I'll test 2,000 bodies, and I am expecting it not to run very well or run at all. As you can see, all of the forces are still being computed and all of the bodies are still being animated, but it is too slow to be comprehensible. The next test I would like to do is erroneous data of using a mass of 0. This may cause an error due to the fact that when you are calculating acceleration, you divide by mass, and division by 0 will cause an error. So I will now try to add a body, and it is being added to the point 0, 0. My next bit of erroneous data will be adding a body onto the same exact point. Upon clicking on the same point and adding a body to the exact same position as a different body, with elastic collisions off, the bodies should instantly combine. And that can be seen. When I turn elastic collisions off, the bodies should be separated. And the bodies have been separated. We'll be testing extreme data with my spiral galaxy. This should be pretty similar to the random values that I added. However, now all the bodies are concentrated to one area. I will be starting with 500 and make my way back up to 2,500 as I did previously. As you can see, 500 bodies run smoothly. I'll now move to 1,000. We will now move on to 1,500 bodies. Next, I will test 2,000 bodies. Now we can tell that the simulation is drastically slowing down. And finally, I will test 2,500 bodies.